Okay, next up, we would like to find the area of the shaded region. And there are going to be two ways in order for us to do this. So we have two methods. We have the Calculus 1 method. That is a simplification / is derived from the more straightforward Calculus 3 method. Okay, so first, for our Calculus 1 method, we know that the area can be determined by integrating from a to b the upper function minus the lower function over dx if x is bounded by a and b. So a good way to visualize this case is case A, where you do have your upper function. So this is going to be y is equal to the cube root of x. Your lower function, which is going to be y is equal to x to the negative 1, so 1 over x. And the functions are bounded by x is equal to 1 and x is equal to 27. The second way is by taking the integral from a to b of the right function minus the left function. Over dy if, let's use different variables for our bounds. So between c and d, if y is bounded by c and d. So a great way to visualize this would be our second case, where we have our right function. So the function to the right is e to the y. So right here, the function to the left is going to be x is equal to y squared minus 3. And lastly, our bounds are y's between -1 and 1. Next up, we have the Calculus 3 method, which generalizes both of them into one clean calculation. And this would just be a is equal to the double integral over region D, which is what's shaded, over D, A. And dA for in Cartesian coordinates is going to be dx dy. And so now let's use them so that you have a better understanding of what we mean. And so for A, let's start with the Calculus 1 method. So the first method, which is using the upper function and the lower function, we know that our bounds are going to be x is between 1 and 27. Our upper function is going to be the cube root of x, and our lower function is going to be 1 over x is equal to y is equal to y. And so let's just write that out, and we get a is equal to the integral from 1 to 27 of the upper function, so the cube root of x, minus the lower function all over dx. Let's rewrite this in, let's break this up actually using properties of integral. So we know the integral of a minus b is equal to the integral of a minus the integral of b. So let's rewrite it. And additionally, we want to rewrite the cube root of x as x to the power of 3 over 2. So it becomes the integral from 1 to 27 of x to the power of 3 over 2 minus, over dx minus the integral actually, wait, let's not break it up. Let's just rewrite it in a form that's more understandable. So 1 to 27, x to the power of 3 over 2 minus x to the power of negative 1 dx. And so we need to remember that the integral of 1 over x is equal to ln x, and the integral of x to the power of a is equal to 1 over a plus 1 x to the a plus 1. So for x to the power of 3 over 2, the integral is going to be 1 over 3 over 2 plus 1. 3 over 2 plus 1 is going to give us 5 over 2. And then the inverse of that is going to be 2 over 5. Sorry, this is supposed to be 1 over 3. Not 3 over 2. So this becomes x to the power of 4 over 3 by 3 over 4 minus ln x. And since it is a bounded integral, we want to take it from 1 to 27. This will become 3 over 4, 27 to the power of 4 over 3 minus ln 27 minus 3 over 4, 1 to the power of 4 over 3 plus ln 1. And this final answer becomes 60 minus ln 27. Now, using the second method, we need to define d first. So we'll be using Cartesian coordinates such that x lies between 1 and 27, as we defined earlier, and y lies between 1 over x, cube root of x. And now we simply take the integral over that. So a would be equal to the integral as x goes from 1 to 27, the integral as y goes from 1 over x to the cube root of x of dx. Let's take y first. dy dx. So first we're going to deal with this part, and this just becomes 1 to 27 of y 1 over x, cube root of x, dx, and this becomes what we had seen previously in the calculation, 1 to 27 of cube root of x minus 1 over x dx. And then the calculation will continue just as it did if we use the calculus 1 method to give us the same answer of 60 minus ln 27. So we can see that the calculus 1 method comes from here. We just decided to describe this part with our words and jump straight into this calculation. Next up, we're going to be doing part B using both. So start with calculus 1 method of B. We're going to be using the left and right one, And so we know that y is bounded by -1 and 1, and x is bounded by y squared minus 3 e to the power of y. So this means that we will be taking a will be equal to the integral from -1 to 1 of the right function, so e to the y, minus the left function, so y squared minus 3 dy. And this will be the integral from -1 to 1 of e to the y minus y squared plus 3 dy. Now this is going to give us, remember the exponent rule here, simply e to the y minus 1 over 3y cubed plus 3y from -1 to 1 since it's bounded. And that is simply going to give us e minus 1 over 3 plus 3 minus e to the -1, so that's going to be 1 over e plus 1 over 3 minus 3. And this will give us our final answer of 16 over 3 plus e plus 1 over e. And that's going to be our final answer. If we use the calculus 3 method, again, we should get the same exact thing. So we, of course, first need to define d. We're in Cartesian. And x is going to be bounded now by this. And y is bounded by this. So the area is going to be, let's put the y1 on the outside because it's easier. So -1 to 1. Y squared minus 3 to e to the y dx dy. If we do this part, we're going to get exactly what we got as the first calculation for the calculus 1 method, and that's going to be -1 to 1. We get x y squared minus 3 dy and this is going to get -1 to 1 of e y minus y squared plus 3, which is exactly what we got last time, dy. Calculation proceeds exactly as it did if we use the calculus 1 method, and we finally get 16 over 3 plus e plus 1 over e. And that's going to be our final answer.